I'm sorry, sir, but do you mean like videos of the meetings or?
Yeah, I'm just started recording. I'm gonna be re posting all these in counts as soon as they finish loading. Okay. All right. So let's show the steps and figure out how this works. I picked an example from the homework. I'm gonna try to pick a few different types, one of each type. That way you have examples and you can finish your homework. Okay. So basically, picture this as 23 degrees plus some decimal number plus some other decimal. So you need to convert these pieces. You're not going to mess with the 23 degrees. You're going to mess with the minutes and seconds. So this is 23 degrees, 28 minutes, 39 seconds. Okay. And usually they use kind of measurements like in nautical stuff. But let's change it into just a basic decimal. So a quick note that you're going to need is that 60 seconds is equal to 1 degree, which means that 1 second, or sorry, 1 minute rather, is equal to 1 over 60 degrees. Write down the formulas real quick. Should always have them to begin with. 3,600 seconds is equal to 1 degree. So that means that 1 second is equal to 1 over 3,600 degrees. So you can solve for the minutes and seconds by just dividing this out. We're not going to show division, but that's how they come up with the formulas. Okay, so these are the formulas that they create in the book and in the notes. Okay, so we're gonna mess with this guy and use this as our conversion factor. We're gonna multiply this out. So take the 28 minutes. All right, so that's gonna equal to, right, change the minutes, that's gonna be the same as 28 times, 28 times 1 over 60 degrees. So I'm shifting over to degrees using this formula, right? So this minute is right there. Does that make sense? I skipped one minor step. Are you cool with me going from here to here? That's fine. Just let me know. If something doesn't make sense, just tell me. Okay. So at this point, you're just gonna divide it out. So 28 times 1 over 60, that's the same as 28 over 60 degrees. So what is that gonna be? Well, that's time for a calculator, right? Let's see what they told us how much to round to. Nearest thousandth. Okay. So now let's do on this side the seconds. So 39, this time I'll show the extra step so you can see what I'm talking about. So 39 seconds is equal to 39 times 1 second, right? Which is the same as 39 times 1 over 3,600 degrees. So I skipped this little piece right here. I went straight to there. You see what I mean? Because at this point, we're in degrees already. We've pretty much done everything they wanted. We just gotta make it pretty. So this is in degrees now. Okay, so let's write it all out. You guys, any questions so far? You still with me? Is that all right? Okay. All right, so now let's write it all out. So 23 degrees, 28 minutes, 39 seconds is
You
the
can't see.
same as saying,
There you go.
oops, that's my tube. It's the same as saying 23 degrees plus 28 minutes plus 39 seconds, which is now going to be 23 degrees plus 28 over 60 degrees plus 39 over 3600 degrees. Oh, pen's running out. All right, still with me, right? So at this point, we got to bring out our scientific calculator or graphing and just make this nice. Let's see. See, this thing doesn't die on me. 28 over 60 plus 39 over 3600. Let's see if we can get it all in one go. That'll be 23.4775. But they want us to round to the nearest thousand. So what would be our answer? Right. Yeah.
23.478.
Yeah, so this is roughly 23.478 degrees. So this is the answer they want. Does this one work? Yeah, change it up. Okay, so from the beginning, real quick, we're changing this into just straight up degrees, getting rid of the minutes and seconds. We use these conversion factors, which are basically our little fractions here, to go from minutes and seconds to degrees. We multiplied the minutes and seconds separately. We got these guys. And then as long as we understand that this is just a sum, it's just the way they write it, they don't put the plus, but it's technically there. Right, so then just convert it and add it up. Okay. Any questions on any of the steps?
No.
That's your first homework question is going to be about this, going from
No, sir.
this to
Well, you
that.
said were recording, so we can go back on it later, correct?
Yeah, I'll upload it. But
I do have one question actually.
mhm.
So where it says 28 minutes, below it it says it basically amounts to 28 over 60 degrees.
Right.
Is there any simplification that has to go into that, or is that the answer?
Well, I simplified it all in the calculator all at the same time.
Oh, okay, got you. But
So
if
I
they're
just
just
basically
asking,
added these three
yeah.
pieces and got this.
Oh, okay, for sure, for sure. But if one of the questions were to ask what is 28 minutes as a degree, would you write it down as 28 over 60, or would you have to simplify it and give the simplified version of degrees?
I mean,
Does that make sense?
yeah, I hear your question.
Yeah.
It's not going to come up, but if they did, you should round it down to a decimal
Oh, okay, for sure. Thank you.
because they want because they asked for a decimal answer. So
Oh, okay, okay. Gotcha.
okay, alrighty. Said my is my mic too loud?
No, just the gentleman right now, but it's okay.
Oh, I
You're
see.
perfect.
Oh, sorry about that.
No, I was making sure. I mean, I think.
All good, bro. Thank you.
All right. Any other questions on this guy?
No, me no.
So this is from the homework, or just from the notes?
This is your first homework question. So you'll have something similar with different numbers. So 4.1, number one. So the first question is going from minutes, seconds to a decimal degrees, and then they're gonna have us do this to the other direction. Okay. So we'll do that right now, unless you have a question.
I'm good, sir.
And I'll scan these as well. I'll make this into a PDF and send it in Remind. All
I
right,
have a
so
question.
yeah, what's up?
For the previous page, I mean, just for the sake of it, could you at least just like make a label just so we know like with the one line and the double line, just so we know exactly which is a minute and second, just in case.
Yeah, so single line is minute. This is seconds. This one's dying as well. Okay. Let me find another one. Wonder if the freeze messed up my pins. They're in my car. Okay. You guys cool on page one? All right, just let me know.
I'm sorry, what'd you ask?
We're moving on to number two. Is everyone cool on number one?
Yes.
Yes.
Over there. We got plenty of time, so you can always ask whatever you want. Don't
Okay.
feel like you can't. Okay. This is going the opposite direction. This is number two in your homework. Convert 3.195 degrees to degrees, minute, second, form. Okay. So basically, you're going to leave that whole number part alone, the three, because that one's already good. You're going to basically change the decimal. The decimal part is the minutes and seconds. Okay. Everything, the three is good. So just ignore this part. So think of this as a three plus some decimal. So we're still going to need our fractions formulas here. 1 degree is 60 minutes. 1 minute is 60 seconds. Okay. All right, so 3.195 is equal to 3 plus the decimal, right? So this is my degrees. So let me make a little note here. Work on converting the decimal. That's where the minutes and seconds will come from. Okay. Do y'all remember? Have y'all taken chemistry at some point?
I
Yeah.
have not.
Yeah,
Yeah.
do y'all remember like all those little conversions from like pounds to ounces to
Oh
whatever,
yeah.
like temperatures and etc. So it's basically the same thing. We're gonna multiply 0.195, and if you haven't taken that, it's okay. I'm sure you've all converted feet to inches and all that at some point. So same idea. If you don't know what I'm talking about, this is the strategy. You want to put the conversion factor, the one you want to cancel on the bottom. So if I want to cancel degrees, I need to have degrees down here, right? So you're going to have 60 minutes over 1 degree. And that's coming from this one right here. Okay. I'm multiplying by a form of 1. So remember, and when you have fractions, you can do 2 over 2, 3 over 3. You can bring in whatever fraction you want if it's a form of 1. This is a form of 1 because we said these are equal, right?
Mhm. Oh yeah, understood. So it'll be like 1/1.
Exactly. So we're setting it up to cancel the degrees. I got my degrees right here. So now I have 0.195 times 60 minutes, which will be, I don't
Oh,
know.
cool.
Now I have 11.7 minutes. I don't have any more degrees, but I still have a decimal. So if you end up with a decimal, you end up converting that part.
Oh, I gotta learn this computer.
So now, next step.
Then you do the factor conversion down to the seconds
Yeah. So now convert.
for the remainder portion.
Yes. Okay. So now you have 0.7 minutes times, use this conversion factor, right? That's going to be 60 seconds over 1 minute. So minutes will be canceling, leaving you with 0.7 times 60 seconds. So the result will be in seconds. So 42 seconds. So now we can get the answer, right? So that means that 3.195 degrees is equal to 3 degrees, 11 minutes, 42 seconds. Just do piece by piece. And then earlier, the last example, we went from here to there, right? Now we're going here to there. Any questions on number 2?
No, sorry.
I do have a question. Sorry.
Mhm.
Um, so when we're converting it to seconds, right? The 0.7 times 60 seconds.
Yes.
What if there's a time where the answer is not a perfect 42 seconds, like a perfect answer? What happens if that answer has a decimal?
It shouldn't, they should give you, since they're only giving us 3 decimal places, it should be enough. Because if they give us more decimal points,
Yeah.
then we have to start talking about like milliseconds, which they're not going to do.
Oh, okay. Gotcha. Gotcha.
Yeah, so they're going
All
to
right.
stick to this. So they're purposely setting us up so we have only thousands place.
Oh, okay, for sure.
But if that happened like on a test or something, I said just leave the decimal and leave it alone. But it shouldn't. It should not happen.
Oh, okay, sounds good then. Thank
I'm
you.
not going to make you do more stuff.
Thank God for that.
Yeah, it's just get the idea. Can you convert back and forth? I just want that's what I want to see. And any other questions? All right. So let's move on from minutes and seconds to radians and degrees. Let me see. Convert degrees to radians. So part A. Oops, and radians degrees. So in trigonometry, they use radians and degrees. So you need to be able to use both. Okay. And if something is too hard or too strange, you can always change 2 degrees and then change back. Doesn't matter. It just depends on the question, but just in general, you could do that. Sometimes I do that. Convert because when you're in radians, you're always in fractions, and if you got to add a bunch of multiples of pi over 7 or something, or pi over 4, it can be weird. But if you change it to degrees, it's a little easier to add. Okay. But anyway, let's find out how to change it. Let's convert pi over 4 to degrees. I'm gonna write both questions and then the formulas. Well, actually, let me see. Yeah, that's fine. Okay. So here's some notes and some formulas. To convert radians to degrees, multiply by 360 degrees over, actually, I'm sorry, 180. 180 over pi.
Oh, okay. Makes sense.
That's another form of 1, right?
Yeah.
Yeah. To convert degrees to radians, oops, multiplied by pi over 180. And if you ever forget which one do I use, the pi needs to be on the bottom to cancel the pi, right? If I'm going to degrees. If I want to go from degrees to radians, I need to cancel the degrees, so it has to be on the bottom. So part A multiplied by this guy, right? These guys will cancel. Or let's show the multiplication real quick. This would be pi times 180 over 4 pi. So the pi's will cancel. What's 180 divided by 4?
Uh, 5 degrees.
45?
Yeah.
Yeah, sounds right to me.
Yeah.
So now we went from pi over 4 to 45 degrees. And I'm gonna send you a unit circle in a bit that you can use whenever you want. It'll have both conversions.
Oh, wait.
Any
Bless
questions
you.
on the multiplication? Okay, just let me know. So for 30 degrees, we need to multiply by pi over 180, which will be negative 30 degrees pi over 180. Okay, we'll put the minus in front just because. So degrees will cancel. 30 goes into 180 how many times?
6.
Yeah, it looks like 6 to me. Because 10 goes into both, 3 goes into 18, 6 times. Yeah, we're good. But it is negative. We'll just do one of those because it's not too crazy. Do you have any questions on number 3?
You said it's negative?
Yeah, the original question was negative 30.
Oh, okay. Yeah, I got you. Got you. Yeah, that's what gets me all the time on the test. When you're doing it, adding, working it out, you got to make sure you put all the signs on there.
True, yeah, gotta be careful.
In the learning management system, Alex, does it matter where we put the negative, whether it's in front or on top of the fraction? I know some of the
Um,
learning management systems are picky.
it depends how smart it is. I don't think it
Okay.
shouldn't technically matter. It should know.
Yeah, because there's not actually like a box for it. It's just part of your
Yeah.
answer.
Yeah,
Okay.
I would always put it in front just to be safe.
Okay.
All right, give me a couple of minutes, guys. We'll pause for a second. Uh, Problem 4 is similar, so I'll leave that to you guys. Move on to something else. So this I'm gonna have to show the question. Sketching an angle in standard position. Let me send y'all that. I'm gonna throw the, what's it called? Where is it? Unit circle in the chat. 1 second. There you go. Oh, here it is. This downloaded through the chat. I'll also send it via remind in a little bit. All right, let me share my screen so you can see it, but also open it up so you can follow along with me. Okay.
Oh,
You'll see
cool.
the circle.
Yes, sir.
All right, so we start at the beginning. Let me get my little marker here. Annotate. Right here is the starting position. If you go counterclockwise, that's considered a positive direction. So any angle that's positive started at the zero and then stopped wherever it's supposed to be, right? So it says if you have power of 4 or 45 degrees like earlier, it's gonna go from here and then stop there. This right here would be
Oh,
considered your standard position. Okay? Does that make sense? If you go negative 45, you'd be going to here.
downward. Yeah.
Even though the positive angle is different, but this would negative 45 is the same spot as positive 315. It's just going in a different direction, ending up at the same spot. Okay? So this next question, okay. Can y'all see the question?
Oh, yeah.
So this is example 5. So if it wants us to go to 225 degrees. Um, Now, real quick, make a note here. This is considered to be the first quadrant. This is quadrant 2. Hard to write with my mouse, so although it's not much better than my handwriting, so whatever. And this is 3, 1, 2, 3, 4. They might ask you, hey, where is this angle at? Quadrant 1, 2, or 3? Whatever. 225 degrees, which is what this question is asking for, would be in which quadrant? If you open
One,
your PDF, right?
3 and 1.
It's going to be 3, isn't it, over here?
Yep.
Oh, I gotta look at that.
Yes, 3.
Yeah, so we're gonna standard position angle, drag it to that point. So here's the angle going all the way to 225, right there.
Oh, okay.
That's it, just hit submit.
Okay.
On paper, you would just draw in that section. Draw it in the third quadrant. Oops, my little thing moved. But nothing crazy, right? But there's a lot of ideas there. I'm hoping what I recommend, what I want you to do, is just briefly go over the sections before we start, because I'm going to jump into the problems, not necessarily, not the theory, okay? I want you to read the theory, and I'm going to show you how to do it and why it works. I'm not going to spend hours proving every theorem, okay? As fun as that would be. Yeah, you can use unit circle and formulas for your exams. Okay, just not worked out problems, just formulas. I'll send you some formula sheets too if you want to use them.
Quick question.
Mm-hmm.
So the question that says it says sketch 0 with a line in it. That means angle, the 0 with a line.
Yeah, this is the Greek letter lowercase theta.
Oh, okay.
So in trigonometry and pre-cal, they use Greek letters for angles.
Oh, okay. Sounds good.
Like alpha, beta, gamma are usually common letters for lowercase though. For
Yeah.
angles, and the most general angle that they use is lowercase theta.
Oh,
Okay,
okay. Thank you.
that's a good question.
Appreciate it.
Okay. Let's look at another. Let's move on to the next one. You guys have any questions on what standard position means or how to find a positive angle? Okay, moving on.
Yeah, I actually do. Just
Yeah, what's up?
So a positive angle would be going counterclockwise, and the negative angle would be clockwise.
Yeah, so if they would have said negative 225, you would be going all the way over here. So yes.
Okay. And for standard position, sorry, can you maybe elaborate on that? Because I'm not sure
Yeah,
what that.
standard means positive direction. Like just the normal angle. Like we went from 0 all the way to 225. Not very pretty, but there it is. All right, next question. Let's see. Okay. I think this is number, I forgot already. Shoot. Six. All right, sketch theta equal to negative 45 degrees. Oops. In standard position. So this will be part, well, let me write that prettier. This is part A. Part B, find the measure of the coterminal angle. So basically, when they say coterminal, they want you to find another angle that represents negative 45 degrees, but they're going to give you a restriction. They'll say between 0 degrees and 360 degrees. So basically, go to this location and find the positive version. So you can do it visually with the chart, or you can add 360 to this, and you can end up at the same place, but going the other direction. Okay. So part A, you should know that it's right here, right? Negative 45 degrees.
So you said the positive way is standard. Is there another word for the opposite way?
Yeah, let me see here. It's not, because they're using the term standard here for positive and negative. One moment. Hmm. Let me open the book. What is the definition of standard?
Sir, what's the word before angle on B?
Oh, uh,
Continual?
find the measure
Yeah,
of the coterminal angle.
oh, okay.
Of the coterminal angle.
Of the.
Of the coterminal angle. 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 Of Oh, I see. So it's pretty a general term. I thought it was positive, but I was wrong. It's basically if it's plotted in the XY plane. So if you look at the circle, right, you know how they wrote X and Y. That's all they mean.
Okay.
So it's nothing
Yeah,
special.
because
It's
on the
just
graph it goes from right to left, right up to left. Yeah.
yeah, center means that you're plotting it on X and Y graph. That's it.
Gotcha.
It doesn't really mean anything. I guess we're not in 3 dimensions or 2 dimensions.
Not yet.
What's up, Tawani?
Yes, sir. Just quick question. How did you get your negative 45 there? Because I thought you said we're going to go in the opposite direction now, right? You
Yeah,
said
so do you have
110.
your circle open?
Yes, I do.
So notice where 45 degrees is, right? If it's positive, you would go to here, right?
Put the plus and the negatives that way they could understand it.
Yeah, this is positive. This way is negative. So it's the same distance. It's just stopping in the negative side. So if we open the circle, get that out again. Can you see the circle? Go. Where's my pencil? All right. So 45 is right there. So negative 45 is the same distance. Just going down here. So the location is actually 315 for the coterminal angle. So the answer that they want, the first answer is they want to just graph it going from 0 to here. And then they want the other version going from here to there. Okay. This is what they're asking for. Draw both. But see, it's going to be the same. But when you graph it on that homework thing, you got to move the thing in the right direction. On paper, it looks the same, but um, okay. Let me switch back to the correct camera. Dang it. This one should be it. Yeah, there it goes. Okay. So part B, they want us to find it. So in order to find it, uh, add 360 degrees to a negative angle. In order to find the coterminal. So negative 45 degrees plus 360, which we saw on the chart, right? That's going to be what?
315.
Yeah, we already know the answer for the coterminal by looking at the chart. But if it was a weird angle that wasn't on there, you just add 360. So that'll basically have you go all the way around the other direction. Okay. So if you're here at negative 45, right, and you add 360, is going to do a flip all the way back to the same spot, right? Because it's 360 degrees. So I'm back at 315. So it's the same thing. Does that make sense? So then you
Yes.
graph it. There we go. Any questions on 6?
No, sir.
Okay. Let's move on to something else.
I actually came up with a question.
Yeah, what's up?
So since we add 360 to a negative angle to find the coterminal, um,
Mhm.
what about for a positive angle? Do we subtract 360 or are we going to get to that?
Yeah, you can subtract 360. So basically find out a way, how do I get to the same spot? Right? You can add
Mhm.
360, you can subtract it. It's gonna just flip or flip back.
Oh, okay.
The other direction?
Mhm.
Got you.
Okay. Let's move on to arc length. I'll leave the others to you. This is number 14. Arc length and central angle measure. So a circular arc has measure 11 meters and is intersected by a central angle of 56 degrees. Find the radius r. So the formula we're going to need is this. So S is equal to r theta. S is arc length. R is radius. Theta is your central angle in radians. If it's not in radians, you're going to have to change it. So they gave us degrees, right? Gonna have to change it. Okay, so step one, change 56 degrees into radians. So 56 degrees would be equal to 56 degrees times pi over 180. You can reduce it a little bit. They're both even, right? I think was it 2 goes into both? 4 goes into both, right? So what does this reduce to? 14, 14 pi, right? If we keep it an exact, it's gonna be that. Yeah. Okay. Alrighty. So now solve for R. If I want to solve for R, what would you do?
When it's so far, so would it be S times central
Yeah,
or
we
triangle
need to move
radius?
this theta over, right?
Oh,
What
theta.
would
I'm
you,
sorry.
what would you do with the
Yeah, to the
theta?
S, to the arc times theta.
Currently, the S is equal to R theta. I need to solve for R.
Divided,
Yeah.
divided.
As divided.
Divide both sides by theta, right? So R would be equal to S over theta. Is that correct?
Oh, over. Yeah. Okay.
So that means that R is equal to S over theta. S was what again?
Arc length.
So 11 meters with the problem set, right? For the arc length. Theta is this weirdness. At this point, you just have to divide it with your calculator. It's not going to get much prettier than that. Um, 11.25. Nearest tenth. What would that be?
Here's 10th, 11.3
11.3. What would be our units?
meters. Or,
Meters.
oh, I see.
So radians is considered to be unitless. So whenever you multiply something else, you take the other one. So this becomes just meters. So the question asks yourself for S, they got to give you R and theta. If it asks for theta, they got to give you S and R, right? It just depends. So it's like this is like a old school algebra problem, right? Nothing crazy. The only extra step was we had to convert this. So don't forget to convert, right? Don't do this with degrees. Okay. Any questions on this guy?
I'm good.
All right, so an arc length, now if you read the book or the notes, is just the distance around the circle. So like if your angle is swept across 45 degrees or something, how far did it sweep? That's your S. Right, the edge of the circle, like how far did you go? Draw you a picture. this distance is what S is. How far did it go? Like from here to here? Like it just swept across. Okay. Area of a sector is basically the area of a slice of pie out of the circle. You slice a little piece off. What's the area? That's what this next part is about. How to find it. So basically, if you want this whole section, that's the sector. Okay. A circle has a radius of 4.5 yards. A sector of the circle has a central angle of 60 degrees. Find the area of the sector. Okay, so here's the formula that you need. Area of the sector is equal to 1/2 r squared theta. Again, we need theta to be in radians, okay?
Above the radius is what? Is that a 2 or
Yeah, r squared then
oh
times
squared?
theta.
Gotcha.
Okay, all right.
Radius.
So we got r equal to 4.5 yards. Then we have theta equal to 60 degrees. Which will be, if you look at your circle, be pi thirds, right? Or you can multiply it and convert it. Since this is an easy one, I'm just going to use the circle. So just plug it in and you should have your area of the sector. So the area will equal 1/2 times 4.5 yards squared times 6 pi over 3. Don't know what that is. Pi is somewhere. Round to the nearest tenth.
10.6.
And notice
Oh,
we went from yards to yards squared because we're dealing with area, right? Should be. Any questions on area of the sector? Do one more example, and that'll be it for 4.1. We'll leave the rest to you guys. This is 17. Angular and linear speed. Okay. Moment. Always get these mixed up. Angular and linear are speed on the circle. So linear speed is a point on a circle moving on, basically traveling around the circle. So like on the edge of the circle, how fast am I moving? That's going to be linear. Angular is how fast it's turning the entire angle or the circle itself. Does that make sense? They're two different things. Uh, so let's write the question down. This one's kind of a word problem. Just trying to wrap my head around it. A Ferris wheel at a carnival has a radius of 24 feet. Suppose a passenger is traveling at 9 miles per hour. Okay, part A. Find the angular speed of the wheel per minute. Part B. Find the number of revolutions the wheel makes per hour. Okay. Oh, I got to change from minutes and hours. Okay. So I'm gonna give you the formulas we're gonna need. Linear speed is V equal to arc length over time, which is equal to S over T. Because we said arc length was S, right?
Yes.
And S was R times theta. We might need that. All right. Angular speed is omega, looks like a W, or lowercase omega, is equal to the central angle over time. So theta over T. And in case you forgot, arc length was S equal to R theta, right? Using all these formulas, you can solve for V, or you can convert V, technically. Because V is equal to S over T, which is the same as R theta over time. But theta over time is omega, right? This is
Yes.
technically R omega. So V can be set up this way or this way. It's depending what you got. Okay. So we might need all these guys to begin. Got all my formulas. Okay. So part A said find the angular speed. What were we given? We got radius, right?
Yes.
What else we got?
The speed.
Yeah, 9 miles an hour.
Yeah, we got the speed. What is in miles per hour? So, and we're dealing with what? We wanted in minutes, and we got feet. So we might have to change to feet and minutes, which will be kind of annoying, but we're back to conversions. Um, but this is V though. So technically, V is equal to 9 miles per 1 hour, right? So convert this multiple times. Let's do the hours first. If I want to get to minutes, um, multiply this guy by what?
That's what I'm thinking about for the question.
Yeah,
Uh,
the form of one, right?
yeah, we're looking for the angular speed, right?
Yeah, we're doing part A right now. So this is gonna be part A.
So why aren't we using the central angle of time?
We have V. We don't have theta, I don't think.
Oh, okay, gotcha. That's why you went to V. Okay.
Yeah, so we're working on this side, but in order to use this, I need to be in feet. And in order to answer the question, they want it in minutes. So I got to convert this to minutes and convert this to feet before I can really do anything. So we're gonna just do our conversions. So we know that 1 hour is equal to 60 minutes, right? Oops, I did it backwards. Oh no, we're good. We're good. Hours will cancel. Now I have 9 miles divided by 60 minutes. The question itself said to use that 1 mile is equal to 5280, 5,280 feet. So we can say that multiplied by another form of 1, I'm going to multiply by 5,280 feet for 1 mile. So that'll cancel this guy. So now I have 9 times 5,280 feet per minute per 60 minutes. So now we're in the units they wanted. But it's all ugly though, but there it is. So calculator time. Let's see what we get. So it looks like 792.
I apologize. We're working out the textbook. How do I get to the textbook?
So when you click Alex on the tab on the
Yeah.
main canvas, it takes you to
Okay.
Alex, and on the home page of Alex, you'll see ebook in there. Or click home in Alex, you should see an ebook. I'll show you in a little bit if you can't find it.
Okay. I should be able to. I remember going there. I just can't remember right now.
Oh, that's okay. All right, so there we got V, and we got the units we wanted. What are we solving for again? Why am I doing this?
To find the angle speed of the wheel per minute.
So we want what variable are we trying to find?
I think we're trying to convert the hour to minutes, I believe.
Yeah, we converted for a reason, right? What was the question asking for? Which variable? Got a bunch of them right here. Which one do they want?
I believe the arc length divided by time.
Said find the angular speed, right? Which variable is angular speed?
W.
Yeah, so this W looking thing is what we need. But in order to solve it, we need theta, which we don't have. So we said, well, technically V is also equal to R times W. We have the V, we have the R, we can solve for omega, right? You see what they're going with this or why I set it up this way? So the reasoning is that right there. So since V is equal to R times omega, that means that omega is equal to V divided by R. And we have V in feet per minute, which means we could now use the R, which is also in feet. That's why we had to convert. Also, the question itself said, put it in minutes. So they just purposely made us do more work. Like, hey, I don't want it in hours, do it in minutes. Like, okay, whatever. So here we are with 792 feet per minute divided by 24 feet. So plug it all in and we're good. The feet will cancel and we'll get some number. I think it's 33. Oops. Whoops. So since the feet are canceling, we're only left with minutes. We still have radians. Whenever you have no units on these circular problems, just say radians per, the time didn't disappear, still in minutes. So V, or sorry, omega, is equal to V over R, which is going to give us this. So we needed these equations to help us. Any questions on this guy? There's a lot of moving pieces there, so let me know.
So that's right here, 5286 feet from.
What's that?
Yes, 5286 feet of that conversion. Sorry, I got lost there.
Oh, right here or before this?
Before when you multiplied it by, yeah, right there.
Right here. Okay, so I'm multiplying by forms of one, right? So you understood here I was canceling hours and minutes to get rid of the hours, and we got minutes, right? That probably made sense. Here to here. So if that makes sense, then the next thing is the same. I want to get rid of miles, so use the form of one for this many feet per mile. Miles are gone. Now I'm in feet. So I got to multiply this out. Divide by 60, and now I have this simplified answer in feet per minute. So this converts hours to minutes. This converts miles to feet. Now I'll have feet per minute. So conversions are just, or you're just multiplying by fractions. And if it's forms of one, you can always do however you want, right? 1 over 1, 2 over 2,
Oh,
it's all good because they're equal.
oh, okay.
The 5280 comes from that's how many feet are in a mile. So if I was going from feet to 1 feet to inches, right? I have to do that conversion 1 foot over 12 inches or whatever. Okay. That just depends.
Are we expected to know those sort of conversions?
You're expected to know the basic ones, but 5280 was given to us in the problem. So this was given, but I would expect you to know how many minutes in an hour, many inches in a foot, that kind of stuff. But the mile one, like, I would probably put it in a test question just in case. This homework actually wrote it in there just in case too, so. Okay. You guys cool on part A? Two-part beat. Find the number of revolutions per hour. Okay, so here you need a, I don't think they gave it to us, did they? Let me see. Yeah, they did. Nope. Okay. Well, we need to convert from radians to revolutions. So one revolution, you agree, is one full circle, right? That's what they mean by revolution. You went all the way around, which is the same as 360, right? So in radians, that would be 2 pi. If you look at your unit circle, our conversion factor will be one revolution over 2 pi. Okay. So we have omega equal to, what was it? 33 radians per minute. All right, did we do that already? No. What was it? Yeah. Okay. So if I want that in revolutions, multiply times 1 revolution is the same as 2 pi radians. So this will cancel. This is technically radians, right? But you don't really write it right next to the 2 pi, but it's technically there. So these will be gone. So now we're going to have 33 revolutions per 2 pi radians, or actually minutes, sorry. 33 revolutions per 2 pi minutes. That sounds strange. Punch it into your calculator, what do we get? I don't know what that is. $33, which would be divided by up. Double check that. Yeah, there we go. We need our parentheses because I'm dividing the entire thing by 2 pi. Oh, this is from the previous question. So when they're asking for revolutions, change your angular speed to revolutions. And that's what we're doing. So 33 rads per minute. If there's no unit there, we said it's going to be radians on part A. Okay, Madeline? So that'll be 5 point. What is it? Well, I guess we'll round to 2 decimal place for now. Did it say? Question. Okay. So once you have the revolutions per minute, they said they want it per hour. So what do we do?
Multiply times 60.
Yeah. So to change this to hours, multiplied by 60 minutes over 1 hour. Which is basically what you said, multiplied by 60. But this is the actual work and reasoning. So hours are going to be gone, or minutes will be gone. That will be what? Times 60?
315.12.
Yeah. So let's round in the nearest whole number, so we'll leave it like this. Oops. Okay. So from the top, question said find the number of revolutions per hour. Take your angular speed, change it to revolutions, and if they ask for a different unit, well, you're gonna have to deal with it. We had minutes, we changed it to hours here. And we got 315 revolutions per hour. Any steps that don't make sense?
Where on the first conversion, where did the 2 pi come from under the revolution?
Oh, so remember we said one revolution is one time around the circle, right?
Mhm.
So that's just equal. That's an equivalent to 2 pi or 360 degrees.
Oh, okay,
But
gotcha.
we got to use radians, so I left it as 2 pi radians.
Mhm.
How did we get 5.25 again? Are we just
I
plugging
just
that in the
the
calculator?
calculator right here.
Yeah.
33 divided by 2 pi. Excuse me.
What page are we on the textbook? Anybody?
Let me find that for you if I can.
Oh, in parentheses? Oh, okay.
Yeah, you do. Because if you don't put parentheses, you're going to think you mean 33 divided by 2, then times pi. But we want 33 divided by both 2 pi. Yeah, this is like page 468 towards the end of 468 is the beginning of 41. This is like towards the end. Around 477 page. All right. So that's 4.1.